Welcome to Chem Sleeping Lab, Episode 1. It is raining outside tonight. We're going to talk about a very basic question. What is a chemical? There are no formulas to memorize in this episode. There is no test. You can close your eyes and just listen. If you fall asleep, that is perfectly fine. When we hear the word chemical, we often think of bottles in a lab with a skull symbol. But in chemistry, the definition is much bigger and much more neutral. A chemical or a chemical substance is any matter that has a fixed chemical composition and distinct properties. By that definition, water is a chemical. Its chemical formula is H2O. It is a chemical. The oxygen we breathe, O2, is a chemical. The salt in your kitchen, sodium chloride, is a chemical. The proteins and fats in our body are also chemicals. So the word chemical by itself does not mean toxic. It does not mean dangerous. It is just a neutral name for matter. To understand it better, we can divide matter into two groups. The first group is called pure substances. A pure substance has a fairly uniform composition. For example, distilled water, which is almost only water molecules, or a piece of relatively pure iron. The second group is called mixtures. A mixture is made of two or more pure substances mixed together without a new chemical reaction happening between them. For example, the air we breathe. It is a mixture of nitrogen, oxygen, carbon dioxide, and other gases. Seawater is a mixture of water and various salts. Coffee is a mixture of water, caffeine, and many other substances. This distinction is the starting point for all the safety discussions we will have later. We need to first know what we are dealing with. Is it pure or is it a mixture? Its properties depend on that. Let's find these two groups in daily life. Pure substances are not only in labs. Table sugar, sucrose, when it is highly refined, can be considered a fairly pure substance. Gold jewelry, 24 karat gold, is as close to a pure substance as possible. Mixtures are much more common. In fact, most of what we touch every day is a mixture. Alloys are mixtures. Brass is a mixture of copper and zinc. Stainless steel is a mixture of iron and nickel. Solutions are mixtures. Sugar water is a mixture of sugar and water. Many cleaning sprays are mixtures. Why does this matter? Because a pure substance has relatively fixed properties. Its melting point and boiling point are quite specific. A mixture's properties change depending on the ratio. For example, pure water under standard pressure freezes at 0 degrees Celsius and boils at 100 degrees. But seawater, because it has salt mixed in, freezes at a lower temperature and boils at a slightly higher temperature. In a factory and in a lab, we handle mixtures all the time. Knowing something is a mixture reminds us that its behavior might be more complex than a single pure substance. It reminds us to check its data sheet, not to guess based on feeling. Now we come to the most important concept for the whole series and for all of the safety management. Hazard and risk are two different words. Hazard is the inherent property of a substance or a thing that could cause harm. It is objective. It does not change because of your attitude. For example, ethanol, alcohol, has a hazard. It is flammable. That is its inherent property. Sulfuric acid has a hazard. It is corrosive. Eating too much salt has a hazard. It can raise blood pressure. Risk is the possibility that the hazard will actually cause harm and how serious that harm might be. In safety, there is a classic formula. Risk equals hazard times exposure. Exposure is how much, how long, and in what way you're in contact with the hazard. If we use ethanol again, ethanol has a flammable hazard. That hazard is always there. If you keep a bottle of ethanol sealed in a cool, ventilated cabinet away from any potential flame, you have almost no exposure to its flammable hazard, so the risk is low. If you pour the same bottle of ethanol into an open bowl and place it right next to a stove that is on, you have very high exposure. The risk becomes very high. The hazard is the same. The risk is completely different. So the core of safety management is not to eliminate hazards. Many times we cannot eliminate them. We need the energy from gasoline. We need the dissolving ability of ethanol. Our job is to control exposure. And there are many ways to control exposure. Substitution with a safer material, engineering controls like a fume hood to isolate the hazard, personal protective equipment like gloves and safety goggles. But before any of those, the first step is always to identify the hazard. We need to know what the hazard of the thing in our hand is. How do we identify hazards? By checking the label and the safety data sheet. Now, the whole world uses a system called GHS, globally harmonized system of classification and labeling of chemicals. On the bottle, you will see diamond-shaped pictograms. A flame pictogram means flammable. A pictogram showing a test tube corroding metal in a hand means corrosive. An exclamation mark means it may irritate your skin or eyes. A skull and crossbones means higher acute toxicity. Besides pictograms, you will see a signal word. There are only two. Danger means more severe. Warning means less severe. More detailed than the label is the SDS, Safety Data Sheet. It always has 16 sections. You do not need to memorize all 16 sections. As a user, you can focus on 4 sections. Section 2, Hazard Identification. It tells you the main hazards. Section 4, First Aid Measures. What to do if you are exposed. Section 5, Firefighting Measures. What to do if it catches fire. Section 8, Exposure Controls and Personal Protection. What kind of gloves or mask you should wear. Remember the numbers 2, 4, 5, and 8. In an emergency, they help you find information quickly. Let us summarize for today. First, chemicals are everywhere. Water is a chemical. Salt is a chemical. It is a neutral word. Second, we divide matter into pure substances and mixtures. This is a basic way to understand the world. Third, and most important, we separate hazard and risk. Risk equals hazard times exposure, and safety is all about controlling exposure. You don't need to remember all of this now. Let it stay with the sound of the rain.